Good day, everyone. This is Engineer Cruz, and on behalf of my co-researchers, Miguel Enrico Robles and Dr. Marla Redillas of the Hydraulics and Water Resources Engineering Division of DLSU Civil Engineering Department, allow me to present our paper entitled Analyzing the Water Quality of First Flush in Urban Stormwater Runoff for Low-Impact Development LID Design. To start with, more than half of the world's population lives in urban areas based on the report published by the United Nations, and by 2050, it is projected that around 68% of the global population will be residing in urban areas. But what is the implication of this rapid urbanization? Urban wastewaters contain a multitude of pollutants, including organics, nutrients, and pathogens that can be directly discharged on receiving water bodies. Aside from point sources, urban areas also contribute to water quality degradation by means of non-point source or NPS pollutant discharges. Both PS and NPS pollution in urban areas raise environmental concerns. However, NPS pollutants originate from diffuse sources and are prone to pulse discharges, making them difficult to manage or eliminate. Moreover, urban stormwater runoff usually exhibits the first flush effect, wherein the discharge in the initial stage of a runoff event contains considerably higher amount of pollutants as compared with the latter phase of the event. The first flush phenomenon can be classified as a concentration first flush or mass first flush. A concentration first flush mainly deals with the concentration of pollutants, whereas a mass first flush is a phenomenon that is both concentration and flow dependent. First flush also has been generally defined as a phenomenon in which the discharge in the initial stage of a runoff event contains higher amounts of pollutants as compared with the latter phase of the event. But despite several attempts to define the first flush quantitatively, the specified characteristics of this phenomenon have been varying among various sources. Hence, the general objective of this comprehensive review paper is to analyze the water quality of first flush in urban stormwater runoff for low-impact development design. Specifically, the study aims to, first, perform a comprehensive review on recently published articles related to first flush. Second, to determine the significant factors affecting first flush based on actual case studies. And lastly, recommend future research directions regarding first flush phenomenon in urban storm water runoff. Due to the large number of publications regarding the first flush phenomena, it is necessary to synthesize all currently available information and publish literature to direct future studies and research initiatives. Therefore, as part of the methodology of this comprehensive review study, a more comprehensive study was conducted to determine the significant characteristics of first flush, particularly its water quality, and the factors affecting the occurrence and magnitude of phenomena in urban stormwater runoff. More so, in this comprehensive review, the definition of first flush from different sources, the first flush values obtained on the studies, and the applications of first flush for the management of stormwater were summarized and then analyzed. And the results of this comprehensive study were also used to identify future research directions regarding first flush phenomena in stormwater runoff. So, one of the goals is to have a clear definition of first flush. For instance, one interesting observation of this study was a vast difference in the quantitative description of first flush phenomena. For example, according to an article by Jaeger in 1987, the occurrence of first flush can be confirmed when the slope of the cumulative pollutant mass fraction versus the cumulative volume fraction is greater than 45 degrees Celsius. Meanwhile, the LETIC in 1998 introduced the 40/20 ratio, stating that first flush can be observed when more than 40% of the cumulative pollutant load was transported within the first 20% of the cumulative runoff volume. Meanwhile, a separate study also claimed that they devised the 80/20 ratio as a criterion for evaluating first flush. This ratio suggested that a significant first flush occurred when more than 80% of the total pollutant mass was transported within the first 30% of the runoff volume. Moreover, a more recent study conducted by Kahanen and Stenstrom in 2020 proposed a mass first flush ratio definition sketch in which the mass first flush for any constituent based on a selected normalized cumulative mass and runoff volume can be determined as high mass, medium mass, low mass, or no mass first flush. In this figure, you can see the distribution of the typical water quality parameters monitored in the reviewed research articles related to first flush. Well, studying first flush typically involves both qualitative and quantitative analysis to determine the extent of the non-point source pollution. Thus, the selection of water quality parameters is integral both in analyzing the occurrence of first flush and when selecting the appropriate stormwater runoff method. This figure shows the typical water quality parameters monitored and analyzed in stormwater runoff and first flush studies. Among the water quality parameters and the most typically monitored include total suspended solids, pH, heavy metals, and biological or biochemical oxygen demand or BOD that appeared in more than half of the reviewed articles. Among the reported studies also, it was found out that TSS was often the primary water quality parameter analyzed due to the simplicity in the analytical method and its association with other particulate matter and sediment wash off by stormwater runoff. Several studies have been carried out also to examine land use types to stormwater runoff pollution characteristics. For instance, it was confirmed that a rapidly urbanizing catchment area may result in significant spatial distribution or variations of runoff pollution, which can eventually increase the difficulties to manage the overall quality of the stormwater. Due to the extreme variability in pollutant load throughout a given stormwater event, the EMC were found to be high, particularly in residential, commercial, industrial, mixed residential, commercial, and agricultural land uses. The high EMC values for TSS was attributed to potential pollution source such as atmospheric dry and wet deposition, road-deposited sediments, and vehicle emissions. Meanwhile, high EMC values were recorded mostly in residential and mixed residential commercial land uses where combined sewer overflow or CSO is present. Next is, for this figure, it shows the box plots of various first flush values generated and gathered from the reviewed research articles on first flush. When a first flush occurs, accordingly, the first flush can be considered as the split flow control criteria. In the examined papers, values of first flush 30 for TSS, COD, total nitrogen, and total phosphorus varied significantly. The weak correlation of first flush suggests that while first flush exists, the values for different pollutant concentrations differ due to many factors, including site, climate, catchment size, land use, among others. Other catchment characteristics also play an important role in affecting the pollutant wash-off rather than this being influenced by impervious area fraction only. Well, we can see that first flush plays an integral role in the design of best management practices, BMPs, or low impact development. The BMPs and LID technologies discussed in these studies include bioretention, infiltration trench, and permeable pavement. What are the key highlights of various case studies reviewed in this paper? For instance, it was recommended by Lee et al. In 2010 that to be able to design the BMP as economically and effectively as possible, using the average rainfall depth was unnecessary, and it would be best to design BMP according to the 7.5 rainfall as lower limit. Meanwhile, Zhao et al. In 2018 highlighted that results indicated in their study of LID practices could influence the urban sediment, dynamic buildup processes, washout, and transport processes. Another study also highlighted that continuous monitoring results indicated that the first 4 hours of runoff exhibited higher concentration than normal levels at the study site, which could be useful in determining the necessary volume for efficient runoff treatment. In conclusion, the comprehensive review paper has identified the differences in quantitative definition of first flush among several sources. In a most recent study, Kahanan et al. Proposed a mass first flush ratio definition sketch to clearly define first flush phenomenon. More so, the generated box plot of various first flush values show that in reviewed studies, a huge percentage of the cumulative pollutant mass was present in the initial 20%, 25%, and 30% of the cumulative runoff volume, indicating the occurrence of first flush. It was also revealed in this study that the characteristics of first flush extremely vary depending on the geographical location of the site, climatic conditions, and the pollutants being quantified. Thus, it can be concluded that in designing efficient LIDs and BMPs for a specific land use, it would require initial monitoring, runoff sampling, and first flush analysis in a study or project site. For future direction, a set of guidelines on the characteristics of first flush in different locations is seen as a potential major contribution to the development of land use, specific stormwater management techniques, which can be beneficial to the improvement of water quality in different regions across the globe. That would be all. Thank you for listening.